Okay, so it turns out that 45,360, which is 2 to the 4th times 3 to the 4th times 5 times 7 was the smallest one, and we found that. 71,280, turns out it factors into 2 to the 4th, 3 to the 4th, 5 times 11. So do you see how, where that 11 came from?
Yeah.
How could we have figured out that was the second smallest one? What did we have to do?
The next prime up.
The next prime up.
Yeah.
Okay, and we replace our largest prime with the next one.
Yep.
That was still small. Now, do you remember our divisibility rule for 11? Remember we talked about that a week ago? How do you tell if a number is divisible by 11?
Wow.
Do you remember?
It's you have the digits. You have it was like +0, -8, +2.
Right, you look at the even digits, or sorry, the odd digits, the first, third, fourth, and add them up and then subtract the even digits. So the odd digits add up to 9. The even digits add up to 9, 1 plus 8.
Which means it's divisible by 11.
So we could have seen that that number was divisible by 11. Pretty cool, right?
Yeah.
Okay, so proud of you guys. This was a fun problem to solve, finding the smallest integer that had 100 factors. And you had a great idea, which was look at patterns in the factors. And in there, we figured out we needed to look at primes.
Mm-hmm.
And then we found a pattern. You had a great idea, which was look at the smallest prime that had a certain number of factors, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We did that on Mathematica. We saw we used lots of 2s and 3s, and then we found a couple numbers where you used more than 2s and 3s, right?
Yeah.
And then from those two patterns, we were able to find that number, which seemed like an hour ago when we started, or half an hour ago, whenever it was. It seemed like finding the smallest integer that had exactly 100 factors was like insane.
Yeah.
But we did it.
Whoa. Yep.
Real cool, right?
Yeah.
That's the power of math. Now the question that James Tanton actually asked. You ready for this?
Yeah. Yeah.
Find the smallest integer that has 100 perfect square factors.
Oh.
So this number doesn't have 100 perfect square factors. It has 100 factors, but for example, 7 is a factor and it's not a perfect square.
No.
Okay, so that's his question is one level up.
Whoa.
Whoa, I wonder how we would do that.
Yeah.
Any ideas?
No, not really.
I'll leave it for you to ponder. Okay?
Yeah. Yep.
All right. Good job this morning, guys. That was a fun family math.